So hello everyone, so before starting on to this video, I want to say that if you have already watched my previous video, that is part 1 of this particular problem, so you can skip this video because the part 1's optimal solution is actually the solution for this particular question. So I will be explaining the same solution that I have discussed in the part 1's optimal solution. So if you have already watched that video, you can skip this video. So if I have already explained why I am creating this video, because in that particular problem, although I have discussed the optimal solution, I have nowhere discussed about this part 2 of the problem and how optimal solution is actually the solution for the part 2 problem. So how the constraints differ in the part 1 and part 2, I haven't discussed anything about that. So that's why I thought to create a separate video for this part 2. So yeah, if you have already watched the part 1 video, you can skip this video. I'll be discussing the same solution. So yeah, let us see the question now. So the question is, construct the minimum bitwise array part 2. So you are given an array nums consisting of n prime integers. You need to construct an array answers of length n such that for each index I, the bitwise or of answer of I and answer of I plus 1 should be equal to the current nums of I. Additionally, you must minimize each value of answer of I in the resulting array. And if it is not possible for a particular answer of I to get the value, then you can simply return, or you can simply put answer of I equal to -1. So what the question is saying that for each and every value nums of I, you need to find a value minimum x. Let's say the value is x. So you need to find the minimum x value possible such that when you do OR operation with x plus 1 with this particular x, the answer should match with current nums of I. So for this particular case, the answer of I will be nothing but the value x. So for each and every nums of I, you need to find the minimum value of x such that this condition should hold true, and this minimum value of x will be answer for that particular ith index. So this is what the question is saying. So let us see the first example and try to understand in more better way. So yeah, this is the first problem. So this is the nums array given to us and this is the output that they have provided. Now they have said that okay, for this particular nums of I, that is 3, nums of I is 3, the answer is 1. That means the minimum x value is 1. Now what is 1 in binary representation? 0, 1. Now what is x plus 1? So we need to do OR with x plus 1, right? So we need to find x plus 1. So x plus 1 is nothing but 2. So how we can represent 2 in binary? Like this. Now if you do the OR operation of both of these, you get 1, 1, that is nothing but 3. So you get x or x plus 1 equal to 3, that is nothing but equal to your nums of I. So that's why for this nums of I, the answer is 1, that is x value equal to 1. Now similarly, if we take example of this nums of I equal to 5, so nums of I here is 5. Now according to the answer, the x value or the minimum x value is 4. So 4 can be represented as this 1 0 0, and if x is 4, then x plus 1 will be what? 5. So 5 can be represented as 1 0 1. Now if you do OR of these two, you will get 1 0 1, that is equal to 5. So you get nums of I. So that's why for this particular nums of I, x or x plus 1 equal to should be 5. And what is this x value? This x value is 4. So that's why the answer for this particular ith value is 4. Now the answer for the nums of I equal to 7 is 3. So let us see how it is 3. So currently the nums of I is 7. So nums of I is 7. Now the minimum x value, they have said that it is 3. So 3 can be represented in binary as 1 1, or we should write 0 1 1. Now x plus 1 will be what? X plus 1 will be 4. That is nothing but 1 0 0. Now if you do the OR operation, that is 0 1 1 and 1 0 0, you get the output as 1 1 1, and this is nothing but 7. So when you do 4 or 5, you get the output as 7, and that is what our nums of I is. So for nums of I equal to 7, our answer of I is nothing but 3. So that's why the answer for this part is 3. Now for 2, there is no such value exists, so we return -1. So I hope you understand the problem, what the question is trying to say. So this is actually we need to find out. Now how do we find out? Because from the question we can't get any hint. The question has just given some equation that this particular condition should hold true. So how we can find this solution? So if you have watched the previous video, that was the part 1 of that video, in that I have told the brute force approach, right? So in this case the brute force approach will not work. Why? Because in the part 1 the constraints on nums of I was, I think, 100 only. So the nums of I max value can go up to 100. I think it was 100 only, but yeah, it was a very small value, I mean to say. Now in this part 2 video the nums of I is very large. So nums of I can go up to 1e9. So this value is very large. So we cannot apply brute force for each and every value of x from starting from 1 to 1e9. Obviously it will give us TLE here only, because then we need to do it for n times more. So n for the outer loop, and inside loop will be going from 1 to 1e9. So it will be n cross 1e9, and n in this case can be 100. So your final time complexity will become what? 1e11. So it will obviously give TLE. So we need to find some optimal solution for this particular part. So here brute force will not work. So how we can find some solution? We cannot get any hint from the question or anything. We cannot find any greedy way, or we cannot find anything. So what we can do? So what I usually do in these kinds of problem is that whenever there is a question of bit related thing, or there is some kind of bit operation happening, I always try to do the entire process in terms of binary representation or in the terms of bit representation. So here also let us see what happens when we do the entire process of x or x plus 1 in binary terms. So let's say our x value is given as 10010010111. So let's say this is the x value. So what will be the x plus 1 value? Simply add 1 to this particular value. So what value will get for x plus 1? So x plus 1 will be nothing but 10010011000. So this will be the value of x plus 1. So okay, for now we can just keep it here as it is. Let's say we try some other value of x. So let's say our x value is 10110000101. So let's say this is the x value. Now what will be the value of x plus 1 here? The value of x plus 1 will be nothing but 10110111100. So have we noticed one thing here? The important part to notice here is that the first 0 that you get from the rightmost part, so first rightmost 0 in the x part is getting set in the x plus 1, and all the values to the right of it are getting unset. So first rightmost bit, in x is getting set to 1. Sorry, first rightmost 0th bit, bit value which is 0. So first rightmost 0 bit in x is set to 1, and all the values that are right to it are setting to 0 in x plus 1. Obviously we are discussing this for x plus 1. So here also you can see this is the first rightmost value which is 0. So it will be set to 1 in x plus 1. So yes, it is getting set to 1 in x plus 1, and all values that are right to it are setting to 0. So yes, they are setting to 0. So okay, this is one observation that we can take forward. Now what can be the other observation? That other observation we will get when we do the OR operation of this x and x plus 1. So let us do the OR operation of these two values. So here x is 10010010111, and x plus 1 is what? 100101100. Now if we do the OR operation, what we will get? 10010011111. Okay, let us do the same for this particular value. So here x value is 10110111011, and x plus 1 is what? 10110111100. So if we do the OR operation, we will get the output as 10110 1 1 1 1 1 1. So do you observe one thing what actually is happening in the OR part? If you didn't observe, let me just show you. So this is the 0 value in X. Now just observe all the values towards its left and all the values towards its right. Same, this is one 0 value or 0 bit in X. Just observe all the values towards its left and all the values towards its right in the OR part. So you see, this is 1 0 0 1 0 0 1, and this is equal to this OR also. So this is same. So this left part is actually equal to this OR value till here, and this right part is actually equal to the OR value till here. Similarly, if you see this particular thing, this left part is actually equal to this part in OR, and this particular right part is actually equal to this value in OR. Now what actually changed? This 0 actually changed from 0 to 1. This 0 actually changed from 0 to 1 in the OR part. So what we can say, what we can see from this particular example, so this is actually what we have done till now is purely observation based. This is purely observation based. Like I have just dry run on some particular example of X value, try to find X plus 1, then I ORed both of the values and I try to get the answer, and then from the observation only I identified, okay, this 0 is setting to 1 and rest all values are remaining same. In these bit kind of questions, you can't have initial idea like, okay, what we will do. You need to do some dry run. You need to dry run on some example in terms of bits. Then only you will get, okay, what is actually happening at the bit level. On the decimal level you won't understand, okay, what is happening with this particular equation. No, you won't understand. You need to do every operation in terms of bit. Wherever there is a question of bits are involving, or there is a kind of bitwise operations happening. So you need to always dry run in these kinds of question wherever there is a kind of bit operation happening, and you need to analyze everything in terms of bits. So this is purely observation based. Now what do we observe here? When we do X or X plus 1, we get some value Y. Now how do we get this value Y? This X has some 0 which is setting to 1, and that is what actually we are getting Y. Okay, so can we do the same thing in the reverse part? Because let me just show you what I am saying. We are doing X or X plus 1, we are getting Y. Now this Y should be actually what? This Y should be actually nums of I, and this nums of I is already present to us. This is given in the question. So if we are getting X or X plus 1, the resultant is Y, and how this Y is getting? By setting 1 0 bit to 1 in the X part. So can't we say that, can we unset a 1 to 0 in Y in order to get X? Because this is just the reverse operation. We are setting 1 bit in X and we are getting Y. So can't we unset the bit to 0 and get X? Yes, we can obviously get that. And this is how we'll be solving this problem. We already have this Y value. Now we need to just unset a bit in Y and we will get one X. And when we do X or X plus 1, we can just check whether this value is equal to the nums of I or not. If this is, it might be the answer, because we need the minimum value. So it might be the answer. But which bit we need to unset in Y? So this is again a question, which bit we need to unset. So let us see which bit we need to unset. So just tell me how many at most bits can be there if the maximum value of nums of I is 199. Obviously there can be at most 32 bits in the integer range. So 199 is actually in the integer range. So in the integer range we can have at most 32 bit. And how many values of nums can we have? We can have n values, and this n can go up to 100. Now tell me, we don't know which bit value to unset. and we can have at most 32 bits, and we need to do this operation for each and every value of nums of I. So can't we do this by checking for each and every bit, because bit number is constant, bit is 32 bit. We will only have total 32 bit, and this is a very small number. So what we can do, for each and every nums of I, we can try to check each and every one that is having inside it. So each and every bit that is equal to 1, we can try to unset it, and whatever x we get, we can just try to find whether this x satisfy the condition or not. If it is, then this might be the possible answer. So this is what we will do. For each and every nums of I value, we will try to unset each and every set bit that is present inside it, and then we will find the value of x. Now there is still a question that how will we find the minimum value of x, because till now we can say that okay, we will get the value of x, but we need minimum value of x. So how will we get the minimum value? So what we can do, we are having 32 bits that are from 31 to 0, starting from most significant bit to least significant bit. So what we can do, we can run a for loop starting from this last bit or the most significant bit, and we can iterate till 0, that is least significant bit, and from largest value possible we will try to make 1 to 0. So what we are doing, we are unsetting the most significant bit. So if we are removing, because indirectly if we are setting 1 to 0, we are actually removing that particular 2 to the power. So if we are unsetting the most significant bit, so can't we say that the answer which we will get, in this case the x we will get, will be minimum possible? Yes, that is the main idea. So what I am saying, let me just show you in terms of code, then you will understand in more better way. So what we will do, for each and every value of nums of I, so I will be going from 0 till I is less than n is nothing but nums size or the size of the array. Now for each and every value, we will try to unset a set bit that is present inside the nums of I. So what you can do, we will start from j equal to 31. We will say iterate until j is greater than equal to 0 and j minus minus. Now we will try to unset a bit. Now which bit we will unset? Obviously the bit which is actually currently set. So we can check if nums of I and this thing is what? We are just checking whether this particular bit is set or not. So this is how we check whether a particular bit is set or not. So we are checking whether in nums of I this jth bit is set or not. So I hope you know the basic bitwise operations, how to check a bit is set or how to check a bit is unset, or how to change a bit from 1 to 0. So I hope you all know these basic operations. So I am assuming that. So this is how we check whether a bit is set or not. So this is saying whether this jth bit in nums of I is set or not. If it is set, that means we need to unset the bit. And what value we will get after unsetting the bit? We will get the value of x. So x will be what? The unset value. So what we can do? We can do nums of I. So now we need to unset this jth bit. So this is how we do unset the bit. So this is tilde sign, tilde. So this. So what we are doing? In nums of I, we are just unsetting this jth bit. And after unsetting this jth bit, whatever value we get, that value is nothing but x. Now we will check if x or x plus 1 is equal to nums of I. If it is true, that means this x is the minimum x that we want. Why? Because we are always trying from the most significant bit. Now if we are unsetting the most significant bit, so the value or the final answer we will get, that will be least possible value, because the higher or the more we go towards the lesser number, the more we go towards this 0 part, we are actually moving towards the least significant bit. So what will give you minimum value? Removing the most significant value or removing the least significant value? Obviously removing the most significant value will give you the minimum value. So that's why we are iterating from the most significant bit, and the first x that will fulfill this condition will be our answer. So for this ith value, our answer will be nothing but x. And now we got the minimum value of x, we can just break. And yeah, this is what we'll be doing for each and every nums of I. So I hope you understand how this problem is actually working. If you still don't understand, you can obviously try to dry run on some example and dry run in terms of bits. Then only you will be able to understand these kinds of problem. So yeah, I hope you understand this problem. Let us see the code now. So yeah, this is the code. So first of all, I am declaring a variable n, which is nothing but size of nums array, and I have also declared one answer vector, which is I am initially setting all values to -1. Why -1? Because question has said that if you can't find answer for any of the ith value, you just need to make sure that that particular answer of I should be marked to -1. So I have initialized all value of answer to -1, and if answer exists, so we can just replace this value with x. If the answer doesn't exist, we don't need to change anything because we have already set it to -1. So initially I have set all values to -1. Then I am iterating on each and every value of nums of I. Now in this nums of I, we need to try to make each and every 1 to 0. So what we are doing, for each and every nums of I, we are running a loop that is from most significant bit to least significant bit. So whenever we get a set bit in nums of I, so how we check this? This is how we check. This is checking if a bit is set or not. If a bit is set or not. If a bit in nums of I, if this jth bit in nums of I is set, we will unset it. So we will unset this particular jth bit, and after unsetting the jth bit, the answer that we get or the value that we get is x. Now we will check whether this x fulfills the condition or not. So x or x plus 1, whether this is equal to nums of I. If yes, that means this is the minimum value of x. So we can just set our answer of I equal to x and break from here. If this value doesn't satisfy the condition, we will try out for next values. So currently we are at 31, we will try for 30, 29, so on and so forth until we get to 0 or we didn't get any answer. So if we didn't get any answer, this value will remain -1. But if we get the answer, we just set our answer of I to x. So we replace -1 to x and we are just breaking. After breaking, it will happen for each and every value of nums of I, and in the end we are just returning this answer. So in this question, what is the time complexity? The time complexity is the outer loop is running n number of time and the inner loop is running 32 number of time, because we are iterating from 31 up till 0. So it is running 32 number of time. So the total time complexity for this solution is big O of n cross 32. So this was about this solution of this particular problem. So I hope you understand this problem. Thank you for watching.